We'll do some examples on DC generator now. That this is the example number 1, that if there is a shunt generator whose output is 200 amperes and the terminal voltage is 250 volts with RA is equals to 0.04 ohm and RF is equals to 50 ohm. We have to find the generated EMF EG. Before solving the question, we will understand something in this question, that first of all output is equals to 200 ampere is given. It is directly means that this output is the load current IL. Another thing which I have when we were talking about the shunt generator and series generator simultaneously, as I said that the armature resistance should be very low and the field resistance should be as high as possible, so that lesser current IF would be flowing in the shunt branch in the shunt generator. If I have it again, RA and RF. This is a shunt generator and a load is connected to it. Since it is said that the load current IL is 200 amperes, this is 200 amps, then resistance RA is given, that is 0.04, and RF is given, that is 50 ohm. Even though if it is not written over there, then one should understand that the field resistance of a shunt generator should be very high. It's the same reason that which we have discussed earlier, that the less current should flow from it, so the resistance should be high. Whereas armature resistance should be as low as possible, because since it is coming into the load part, and if it is a higher resistance, then it will also consume some power from generated power EG, and if a bigger part of this load, bigger part of this power actually is consumed in RA, then load will not be having that much sufficient power which it was required previously. So RA should be as low as possible, as it is given 0.04 ohm, and RF should be as high as possible. So even if RA and RF are not given, one should understand which is RF and which is RF. Now coming back to the original question, that I have IL, what we need to find is the EG. What is the formula of the EG? EG is equals to VT. This is the terminal voltage, VT plus IA into RA. And what IA is actually, this IA is equals to I shunt plus I load current. This is well known to everybody. So IA is equals to I shunt plus IL. So IL is already given to you. You need to find the I shunt. If you find the I shunt, then VT is given to you, terminal voltage, and RA is also given to you. Then we can find the total EG. So before finding the EG, we need to find the shunt current. So I can find the shunt current is by VT by is the terminal voltage VT divided by the shunt resistance, that is V by RSH, which is 250 divided by 50, which is equals to 5 amperes. Now again, if I see that I shunt is very much low as compared to the load current. So this is important again a discovery of us that shunt current should be as low as possible. It should not be below the permitted value. It should be that much only so that it will be able to create the flux which is required to have the generation of electricity. I shunt is very small in comparison to IN. So from this formula, I can have IA is equals to I shunt is 5 amperes plus my IN, that is 200. So IA is equals to 205 amperes total. So from this formula I can have VG is equals to VT plus IA RA. VT is, then my VG will be coming as VT is equals to 250 plus of IA, which is coming from this 205, multiplied by my RA, which is 0.04. This EG is coming to be 270.2 volts. This is how we found the EG. This is a very easy example just to show that how shunt generator is behaving. We'll be doing some more difficult problems on DC shunt generators.